page 21. Okay, I don't know, I'm just going to call this summary. At the end of this unit, I'll give you a nice cardstock chart where it kind of summarized everything. I'm not going to say that's going to be the silver bullet, but it's going to help you out, right? We're on page 21, guys. So I guess we started off with, I'll go off to the side here, arrangements with repetition. Morning. Arrangements with repetition. That's how we started off with, or at least we considered repetition was allowed. So in other words, you also have to make sure you have an unlimited supply. Okay. So we would say, for example, if you made a 3-digit password or passcode, right? You would say, well, if you have digits 0 to 9, that's 10 times 10 times 10, right? Every slot, however many events are happening, would have the same amount. That wouldn't change. So you would essentially say, well, it's really the options I have to the power of the number of events, right? What you have to pick from to the power of how many events am I filling, how many slots am I filling, right? Which is really, I want you to start thinking N and R as well. Page 21. N, R. Okay, so N. So this type of question would be solved by saying it's just N to the power of R. Right? Then we also considered arrangements without repetition. So that was, in a sense, a restriction that was placed on us, right? I don't want you to be stuck with 10. So, but I think for this summary, I will stick with just, we have 10 options, but it could be letters. Then you have 26. It could be letters and digits, right? Then you have 26 plus 10, that'd be 36 options. It could be special characters, you name it, right? So don't just be fixated on the 10. But in this case, if the repetition was not allowed, you would obviously slowly decrease in the number of options you have. Or maybe I'll say it this way. This would be, you would start off with 10 factorial, but it stops after 8, right? It doesn't go 7, 6, and so forth. So you would actually put a 7 factorial underneath, because that would be 10 times 9 times 8 times 7 factorial over 7 factorial. And if this is like, what? I'm not going to use that very often, this kind of notation, but if you ever seen or were asked to write something in factorial notation, I basically try to cancel out whatever I don't need. Okay, so these are both the same thing, but this is the one I want you to really internalize. This is a permutation where you have n number of options, right? And you're going to arrange that in r number of ways. So that's how they're different. So here you would have also, right, you need to have an unlimited supply. In this case, you would have a limited supply. That's another thing. And why am I using that wording? Well, when it's saying, hey, you've got, a word, let's say math. How many ways can you arrange the letters in the word math? You are limited to just those letters, right? So it's a limited supply. Automatically, you should be thinking, oh, we're in this category here. So example, arrange math, right? Arrange math, and then you would have to say, right, you could use the fundamental counting principle, no problem, right? Where you start with 4 times 3 times 2 times 1, right? You're essentially you're using up all your options and you're having as many slots as you have options. So this would be in permutation notation, or would be 4p4, right? Because you're using up all slots. So it's a bit weird to think of it that way, but it is 4p4, right? Again, I'm not gonna ever make you use one over the other. I actually tend to do a lot of my examples. I tend to stick with fundamental counting principle because to me this is more. It's better to like visualize what's happening. Okay, so you need to keep that in mind. Okay, so those are basically the two main concepts that I wanted to cover, and it actually lies right here, right there. Okay. And this is not gonna obviously cover everything we've done, but I wanted to bring that out, right? And then maybe I will just say here on my third column here, sometimes you're gonna have to split into cases, right? And you can always do that, right? Morning. A password starts with A or B. A password starts with A or B. How many ways can you, and obviously we're assuming letters, right? I'm going to say assume 26 letters. How could you solve that? Right? So let's assume our password has four slots to fill. Okay. This is on page 21. So we have, you can say B or L for the first. And so that means that you technically have two options to put in the first slot. If this had allowed for repetition, right, we would go 2 times 26 times 26 times 26. If you see this, you're like, oh, okay, they're allowing repetition here, right? That's what you should see. However, some of you might say, well, I don't know, this is kind of confusing to me. I need to do the cases, Mr. Erickson. I need to go where there's a B and where there's an L. So you only have one option, 1, 2, 3, 1, 2, 3, right? This is still 26 here, 26, 26, 26 there. You should realize that, oh, I'm going to get the same answer. I don't know if you see that, right? Because you're going to end up adding these two answers here. This is 26 cubed, and this is 26 cubed. We're going to add that up. This here, sorry, I'm running out of runway here. That's what happens when you don't plan, right? You plan to fail. You heard of that, right? Failing to plan is planning to fail. But I still hope that you get something out of it. Let me zoom into that, just that corner there. Both of those are going to give you the same answer. So I need you to start seeing that, because my key is often going to be like, what? I did it a different way. If you get the same final answer, you're good to go, right? So you just need to see it that way. We assume repetition. Okay? We assume repetition. If there's no repetition, how would this change? No repetition allowed. By the way, can you use permutation for this one? Can you use permutation in this case? The answer is no. Permutation like this notation only works when you are not repeating, right? Because you slowly go down, right? So this would have to be done using fundamental counting principle. No repetition. How would this change? I'm going to just use the BL like this. You can have B or L in the first place, and you have 1, 2, 3 more slots to fill. Okay? Eight. I just realized when Nick turned around and looked like, what is he talking about? Sorry, guys. I did make a mistake, right? A or B, correct? Where does he get B and L? Sorry, guys. Can you change that, please? I don't want you to look at this and be thrown off. Yeah, AB. Where did I get BL from? I don't know. This is a bunch of BS, right? That's what you're thinking. Anyways, A or B. Sorry about that. The point is still you've got two options for the first one. However, please don't make this mistake. Students will go, oh, 2. So what am I left with in the next one? What do you think a lot of students put down here? They'll put down 24 because I've used 2, right? I don't want you to think this way. I want you to think when you see A or B, think of branching off. You're either taking A and then you have 25 left over, or you're taking B and then you have 25 left over there. So I want you to think of this is happening and then I have 25 for that one, 24, 23. That's how you should be thinking of it. This is the quicker way of doing it. And then some of you are still thinking, what is going on there? I don't get that part. So let me do this one more time. If you have an A, that's one option, or a B, that's another option that you can do. So 1 there, 1 there. So if we consider the branch where you're going to A is gone, so that means you have 25, 24, 23. Okay. Then we're going to consider a password that starts with a B. Again, 25, 24, 23. Okay. You should see it in this. In this, you should be able to see why it is that I'm going 25, 24, 23. Okay. So regardless if you do it this way or that way and then add it up, because remember, when you do split it into cases, you need to add up your answers. And you get the same answer. It's going to get messy. I'm going to use a red pen for this part. This part right here, this part, how could you rewrite that using permutation notation? I would say this, 2 times, this is what? How many options do I have there? 25. And I'm going to use pick a lot. 25 pick, how many slots do I have to fill? 3. And we're going to get our answer that way. This is just 1 25 pick 3. And this is also 1 25 pick 3. I have no idea what, let's use our calculators. I'm not sure if you got that because I had a number of students saying, how did you get the P? Where did you get the P from, right? So grab your calculators. I need you to know where to find that, right? And the quickest way is going alpha window. I know I told you alpha trace before. Alpha window is the best way to go. So you press alpha, then window, then you see this option. And I can tell you already, if you look up here, we're going to use 7, 8, and 9. These 3 we're going to use in this unit. Okay. But right now we're going to use the P. So you select that one, and then just type in, we're going to go with this one here, 25, pick 3. Figure out what that is. That's 13,800. In this case, I'm going to multiply this answer by 2. So it's 27,600. Okay. The one next door here, that's going to get messy. I'm just going to add them up like this. But we know that 25 pick 3 times 1 is just 13,800. And you add up another 13,800. you get the same final. You get the same 27,600. Okay. So regardless of how you approach something, chances are if you're doing it right, if you're not, making a mistake along the way, you get the same answer as me. I think I'm not going to do the equations here, and I'm not going to do like that. We will do right after this. I'm actually going to go to the page where I want you to try solving an equation using factorials. Okay. But this is it for the review. I hope it helped you a little bit. And grouping, I will also just go to the lesson where I ended up with grouping, and I will review that. But this is kind of like where I want you to be. I want you to be comfortable with this. And I didn't cover tree diagrams. Most of you are okay with tree diagrams, right? Did you know you could make a tree diagram with these ones too? But your roots, you know how many roots you would have? 27,600, right? So that's like, we can't do that. We need software for that, right? But when it's smaller events where you have like 2 shirts, 3 shorts, and 4 socks, those ones I would expect you to make a tree diagram for. Okay? But the idea is always the same. Like as you have slots to fill, right? You go with, oh yeah, I did. Can I just, over here, the 1098, I told you it's NPR. In this particular case, it would be, you've got 10 options, and you would pick three slots to fill. Okay, in this particular case. All right. So let's go to, I'm going to get you to try one equation to warm up today. Because equations are a bit of a pain sometimes. And I made one up. Go to page 16. Kind of like the bottom half of 16. Leave half of it for the equation that's above, right? But halfway through the page, kind of like the middle hole here, right next to it, copy this equation down. And we're going to try to solve that one. You're going to try to solve that one. Okay. Back to 16. I'm just going to use this one here to show you a common error that I see students make. When it comes to the restrictions, I get a whole, so maybe just watch, don't necessarily copy things down here, but if I'm asking for restrictions, some students go, oh, that's equal to -1, and this is equal to 1. No equal signs, okay? You are basically saying the only way the top would work is if n is greater than or equal to -1. That's what you need to say. And the denominator would only work if n is greater than or equal to 1. Okay? And so this is the bigger one. This, if you think of a number line, if this is 0, right, this is 0, this is -1, this is 1, right? If you're saying, hey, n only works if it's greater than or equal to 1, like you're basically stopping it here. It's never going to even get to the -1, so you don't need to worry about this one. It's not going to happen if you say this has to happen, right? So n has to be greater than or equal to 1. Maybe another way of looking at it is you're basically asking yourself, if you have n plus 1, when is that going to be 0? When is the top going to be 0? Because 0 is the smallest you can get. If it's negative, you cannot take the factorial of a negative. And so watch this. What happens to this plus 1 when it comes over? It's -1, right? So that's how I come up with the first restriction there. And then for this one, you go n minus 1 is equal to 0. You're basically figuring out what values of n would make it 0. When this comes over, it's n equals plus 1. And that's how I come up with that second inequality. It's basically inequality, right? But it's a restriction in this case. That's mistake number one. No equal signs, just greater than. And give me the ultimate restriction, all right? Another mistake I see is this. Students will be like, I'll expand this one. So they go n minus 1, so n minus 1, n plus 1. It's like, wait a minute, like this is now going up. If you think about it, n negative 1 and n, right? It's actually going up. This is not right. If you were to expand this one, it would actually be n minus 1 followed by n minus 2. Yeah, right? You should quickly realize this isn't going to get me anywhere because I'm not going to be able to cancel out the top at all, right? So some of the things to watch out for in that case. So I told you not to copy it because that's not how you would solve it, right? I have a key up on this, so if you need to look it up, just I think last Thursday it was posted. So this is new, right? I would make sure I make it stand out because if you ever look at the pages assigned underneath, that's your textbook, and this one is actually straight from the textbook. So if you ever want to like expand your whatever we're doing, you go there, and the answers are towards the back of the textbook. Maybe I'll take some time later to show you how to find them because some students seem to have a hard time finding the answers. All right, so let's do this one. Start the same way, right? At the top, n would have to be like the smallest n can possibly get to is negative 1 because that would turn this into 0, right? So it needs to be greater than or equal to that. At the bottom, n has to be greater than or equal to 1, right? If this is 1, if you go 2, 1, then you get to 0, right? So this is the ultimate restriction. That takes care of everything. I will expand the top. This expression is bigger than that one. So I will go like this, 3n plus 1. The next one would be n, right? n plus 1, n. Then it's n minus 1. And that's where I see, okay, this is going to cancel out. Don't forget the factorial, please. Some of you are not putting the factorial down because technically this continues, right? Until you would, once you find the value of n, until you get to like 1, right? So this cancels out and you're left with 126. So that's 3n plus 1 times n is equal to 126. So here you have options. I would tell you that you have options, but my suggestion would be if possible, it's not always possible, but try to see if you can divide out the 3 to get rid of the coefficient of 3 here. So what I will try is 126 divided by 3. I'll see if that works out, and it does. If I divide this by 3, I get a nice whole number, 42. So I'm going to go divided by 3, divided by 3, that gets rid of this, turns into 1, and so I'm left with this, right? So I can distribute that. Right, so that's n squared plus n is equal to, this is the big mistake I see as well. Students just write down 126. It's 126 divided by 3, that's 42, okay? If you find your roots and they're decimals or some like negatives, all of them, double check your work, right? Something went wrong. And here you just go n squared plus n minus 42 is equal to 0. That's where you want it. So you use your 3 methods, factoring, using your quadratic formula. I'm going to use the quadratic formula today. So to find n, we go negative b plus or minus b squared minus 4 times a times c. Watch out, c is negative. All over 2 times a. Okay. That would be negative 1 plus or minus. These two negatives, these two negatives here will turn into a positive, right? So it's actually, let me just figure out what that is in the root there. 1 minus 4 times 1 times negative 42. That's 169 there over 2. And that's where you get your two roots, right? So n sub 1, it's going to be 1 plus root of 169 over 2. N sub 2 is 1 minus 169 over 2. Okay. Some of you use the graphing method, that's fine. So you just, can you see that on the screen? Yeah. So 1 plus, so Dirksen, you missed something. It can be fatal, right? I missed that negative. Phew. Could have made a big difference, right? So you got to go negative 1 plus root of 169. I'm going to divide that by 2. I get 6. The next one, I'm just going to copy paste that expression. And instead of adding, I'm going to subtract. Divide that by 2. Oops. That's negative 7, which we know is not going to work, right? This is not going to work. This is our answer. And you should be able to check plugging that in. You plug that in, you get left side is equal to right side, and then you're good to go. And by that I mean plug it in to the very original here, right? This one here. And I'm not going to show you that part, but I just wanted to review equations with coefficients other than 1. But what was that? This, right? If you ever have something like that, don't fear it. You're just gonna have to somehow get rid of it, okay? And chances are it's gonna cancel out, or you're gonna be able to divide it out just fine, just as you did here. All right, let's keep going. Grouping. Go to page 20. So it's a mix today, right? It's a remix. So yes, I'm going to be talking more than I'd like to, and that you would like me to, but hopefully you hang in there. Okay? 2-minute break. Sweet, right? There we go. Page 19. So make sure you pay attention. So this is grouping, okay? That is actually very popular, and when it comes to the province, they are most likely gonna have something where you are supposed to keep things together, okay? And so we have this example where on page 19, where you have 8 paintings, and so at first it's kind of like your universal, this would be your universal set, right? How many ways could you arrange those 8 paintings? It's 8 factorial or 8 pick 8, however you want to do it. You don't have restriction, like they could have said, hey, you have 8 paintings, but you need to have like you can only arrange it in 4 at a time or 5 at a time, right? There were no restrictions in that sense, so it's just 8 pick 8. Then we threw in a curveball, right? The artist wishes to keep 3 paintings together, and I used pink there, and maybe I should, right? Highlight that we're gonna keep those 3 together. You can mix them up amongst themselves, but they need to be beside each other. And that's why there is a 3 factorial, because you can arrange within that little bubble. But then at the same time, that group becomes like one big slot, right? So we count 1, 2, 3, 4, 5, 6. There were 6 big slots created outside. So it's almost like zoom out. You have to have the zoomed out arrangements and also the zoomed in within that little group you've created. Okay, so I hope that makes sense. Then we went into creating 2 groups, right? 3 need to stay together, and another group of 4 need to stay together. So now we're circling 3 here and 4 there. And within each of the small subgroups, you can make, right, arrangements. You can switch them up. That's why these 2 come in there. But then we need to zoom out. At the very end, I always put it at the back, always. My key, that's always at the back. I zoom out. This one here is one slot. The next group is another slot. And then I happen to have that one single painting that can go anywhere in between them, right? Or on either end. So that's my third slot. So that's how I have this 3 slots that come in here. Okay? That's how this is created. And by the way, this is multiplying. Okay? Now, we didn't actually calculate the answer here. I see. Let's do that right away. And at some point, I'll give you shortcuts, right? 3 factorial is 6. 4 factorial is 24. So 6 times 24 times 6, right? So it's 864 ways. There we go. You can just type in the factorial if you don't remember. But this is the formula that will help you come up with this every time. This is the formula. Some students like to just go with this. Some students are like, I'm gonna do my fundamental counting principle. I'm gonna make a bunch of slots, and I'm just gonna do what you did there, and just set it up like that. That's maybe most of your ways to do it. But watch this. You basically take the objects in the first group, you factorial that one, times objects in the second group, you factorial that one. See how we did that, right? That would continue for as many groups as you create. Okay, for as many groups as you're creating, that would continue. The last one here, this is the green one. You take your total. Let's try to come up with a 3 using this formula. We go 8 minus 3, that's 5, right? Minus 4, that's 1. But then you have to add the number of groups you've created. So we've created 2 groups. So 1 plus 2 would be 3. That's how you come up with a 3 here. So that's this formula right here. And so if you were thinking the whole weekend, what in the world is that? It is what I did, but maybe this is easier on your study sheet, right? This one right here. Because how are you going to make this? I mean, you can just copy this example, boom, and you're good, right? So let's keep going. I'll do another example here on page 20 with you. I didn't assign 20. I don't think so. There are 8 dogs and 5 cats in a class. Okay, just making this up. How many ways can they be arranged in a row? Maybe this is bring your pet to school day. I don't know. How many ways can they be arranged in a row if there are no restrictions? No restrictions. What is my n here? I have 8 plus 5. I have 12 options here. Okay, 12 options. So if I wanted to arrange them, sure, you can go 12 lines, but I think I'm just going to go, should I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. So you've got 12, 11, 10. So as you go down, this is going to go to 1, which is really 12 factorial. Or you can just say from the 12 pets, you pick 12. Thank you. As I said, 13. So we're just going to add a line here. Watch. Look at my fix here. Hey, like nothing ever happened. There, and this is going to be a 13 factorial. Thank you. So this would be what? 13, pick 13. Okay, very important. Thank you. Let's figure out what that is. It's probably a big number. So you can go 13, pick 13, or you can just go 13 factorial. In this case, they both mean the same thing. Okay, I'm going to go alpha window, and I'm going to go 13, pick 13. Whoa, right? Do I have that right? Yeah. I'm just going to copy that. Got to make sure you got this number down right. There you go. Ways or arrangements, whatever you want to say there, that's fine with me. Yeah. So in this case, R is 13. So you have 13 options and you're arranging them in groups of 13 every time. What if we have all dogs? What if all dogs are kept together? So let's do the 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So how many dogs are there? 8, right? 8. So you need to count 8 of these slots. 1, 2, 3, 4, 5, 6, 7, 8. And they need to be kept together. And that's for sure within that group, you're going to have 8 factorial happening right there inside that group you've created. So to write this out, what would we do? We would take the objects, or in this case, the number of dogs, right? Factorial that. And now we need to zoom out. This is one big slot. 1, 2, 3, 4, 5, 6. That would be your answer there. Using the formula, I would say, well, objects in group number 1. There's only one group, correct? Okay. Now I'm going to do the total, the one that says total in it. 13 minus the number of objects in that group. And how many groups have you created? In this case, there's just one. So you got to go plus 1. And make sure you put a factorial at the end of it. Okay. And that would be 8 factorial over times 6 factorial. If you do the math here, which apparently I can't do today, right? But I checked. This is 6, right? Let's figure out what this is, because I do, unless the question, sometimes I'll have a question here and there that is so big, your calculator won't be able to do it. So I'll just ask you, write out what it would be in factorial, right? Just stop right there. But these numbers are doable. So let's grab our calculators, practice that, because it would be too bad for you not to get the final answer. 8 factorial times 6 factorial. I just pressed 9. Alpha window 9. Boom, right? So there it is. That's 2903040. So if you like your commas, right? It's okay to have a comma there, but I tend to not have them. And it should be less than your previous. It should always be less than your universal. I tell my students, if your answer is bigger than no restrictions at all, then maybe double check something went wrong, right? What if all cats are kept together? That's, I think what I will do here is I'll say, well, how many cats? We've got 5. So I'll just say, that's my group number 1. This is G1. Okay. And then I will go total, which is 13, minus 5, plus, in this case, I've just created one group. Okay. So this is total minus G1 plus number of groups. That's what I've done there. Is that small or what? Here. There you go. So that'll be 5 factorial. 13 minus 5 would be 8, plus 1 is 9. Okay. So I'm just going to copy paste my previous work and just replace 5 and 9 just like that. It's 4, 3, 5, 4, 5, 600. Please. Oops. Can't see that because I zoomed in. Sorry here. There it is. Can you try D, E, F, leave it for now, but just try D and E. Can you come up with the answers to D and E based on what I've just done now? Let's try this now. Thank you for trying, guys. Dogs sit together, G1. Cats sit together, G2. We've got two groups. Okay? So what I would do if you use the formula, I will do the formula here. Dogs, I gotta make sure that's 8, right? 8 factorial. Oh, still frozen. Let it go, right? There you go. 8 factorial. Sorry, guys. G1, G2, two groups, right? Usually it don't go more than that, but it could, right? Actually, I shouldn't say anything. Just follow the formula and you'll be fine. Cats is 5. And then I'll do the bracket here. I'll be like, well, there's 13. There were 8 in the first group, 5 in the second group. How many groups have I created? 2, yes. I've created 2 groups. And that would be 8 factorial, 5 factorial. And what are we at here? 3, right? Sorry. That's 5. 2, right? Yeah, sorry. It's messing me up because my original was different. And I always keep changing to make it better, hopefully. And then so thank you for following along and correcting me. Yeah, because technically, just think about this: just 2 big dashes, right? That's all you have to flip at the end. That's all you have because you're restricted to them being together. So that's that. I'm gonna have to redo this one because it won't match with mine. So I'm just gonna change the 8 and the 5, and 2 is just times 2, right? 9 million and something ways. And it should be less, right? Like, because you're restricting even more, right? Did I get that right? 800, 676, 9. Okay, good. Dogs sit together. Dogs sit together. Manfred and Belinda, both cats, sit beside each other. So dogs, we've got 8. Manfred and Belinda would be 2. And then we have 13 minus 8 minus 2 plus 2. So in this case, these actually cancel out here, right? If you didn't catch it, that's okay. So that'll be 8 factorial, 2 factorial, and this would be 5, right? 5 factorial like that. I'll just copy paste. It ends up being the same, right? 825, 825, there we go. Yeah, that's just how it goes. Okay. This is this is pointing to the future, this one right here. How many ways is it when Manfred and Belinda do not sit together? I'm going to use indirect reasoning, okay? So how about Manfred and Belinda sit together? Let's figure that one out. I'm going to pause this one. I'll come back to it down the road because I will actually devote time to this scenario. I don't want to spend time right now because what's the point just touching on it right now? I do want to talk about one more thing. Sorry, guys. I know you're probably sick and tired. If you didn't do the homework, it was 22 to 25. Actually, I said 22 to 24, but I posted everything to 25. That would be dealing with grouping. That would be dealing with permutations, stuff like that. So if you need more practice, that's where you would find it. And there's lots of space for you to do the work right there. Okay? So it doesn't go away. I just wanted to maybe spend more time to clarify what we've been doing so far. Let's keep going. So I'm going to take you. Yeah.
Like, why? I don't really understand. There's three groups. You know what I mean?
There's only two groups, right? That you've created. Like all dogs sit together and the two cats sit together. So let me just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So you've got your 8 dogs, 2, 4, 6, 8, and the two cats that have to be together. So if you think of big picture, this is 1, 2, 3, 4, 5. Good question. There's always good questions. Okay, keep asking. Especially with me on a Monday, right? You gotta be really awake for that, right? Okay, question 26. I will touch on this. 26. Okay, I will highlight this. What if you have scenarios where there are identical objects present? Okay, what if you have identical objects? What we need is we need to divide out the repetition. We can't double count. And this is on 26. Okay, I will use a different color. Identical objects would be things such as marbles, shirts, things that if they had the same color, you wouldn't be able to tell them apart. Two blue shirts, if you buy them from the store, whatever, you couldn't tell them apart really if they're the same size. Everything is the same about them. That's what we consider identical. Warning: two people wearing blue shirts are not identical because I will trick you sometimes. They're just because their faces are different, right? So just keep that in mind. Arranging people wearing the same color shirt would count as unique or distinguishable. Okay, no repetition here. Um, the formula for permutations or arrangements involving identical objects. So I need you to make sure you understand what this is. So you're not just writing down P is equal to that because you might think it's probability down the road. It's just the number of permutations would be n factorial, so the total number of objects present. And then you would have to divide by the repetition. So these will all be numbers down the road. Okay, so number of the first set of identical objects, second identical, and what dot 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 means that this could continue for as many repetitions as there are. Okay, so let's consider this. How many ways can the letters in the word eyes be arranged? Notice this, right? There are two E's here. Two E's. They're identical. So that's a problem for us. We cannot distinguish between them. Okay? We cannot distinguish them. There's no identifying aspects where one E is different than the other. Okay? So you would say 1, 2, 3. How many letters? 1, 2, 3, 4, right? 4 letters. So you could say, well, it's 4 times 3 times 2 times 1, right? But you have to divide out the repetition. And so how many, in this case, you only have 2 E's. That's the only thing that's repeating. So we just go 2 factorial. We get rid of those 2 permutations. We don't count them. So this would be essentially 4, like this would be 4 factorial divided by 2 factorial. And we can just go 4 times 3 times 2, so we remember how to do this. You could plug this into your calculator, of course you could, but this would be 12. 12 arrangements. Let me just use a highlighter here. the two E's here, that's what this is supposed to get rid of. And I need you to understand this. Because if I put this E that's over here, if I swap these two, would you notice a difference between those two arrangements? If I put this E over here and that E over there, it wouldn't make a difference. So we don't want to count that. So we divide out those permutations. It's almost like we're not going to count switching them. So divide by 2 factorial. Okay, let's do another one. 1, 2, 3, 4, 5, 6. N is equal to 6 letters. What's repeating here? The 2 C's, right? 2 C's repeat. We're going to divide out. So we're just going to go 6 factorial divided by 2 factorial. There's it. It's not always going to be 2, guys, by the way. Okay, so that's just 6 factorial is 720 over 2. So that's 360 ways or arrangements. One more at the end here. Eyeballs. 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8 letters. So from now on, you want to look for repetition. I did pre-calculus before, pre-cal. Didn't have any repetition, but now you have to watch out. So there are 2 E's, 2 L's. Anything else? That's all I see. Okay. So you would go 8 factorial divided by, watch this, 2 factorial, that's the 2 E's, and another 2 factorial, it happens to be 2 L's as well. So 8 factorial is 40,320. 2 factorial, that's really just 2 times 2. So that's 10,080 ways. I'm going to use orange here for this. And I'm going to use green for the L's. All I want you to do is page 27, D. That's all I want you to do, Canada. From now on, I would expect you to divide out repeated objects. We're going to do more about that tomorrow. Make sure you know your grouping. Make sure you try at least one of these. That's it, guys. Thank you very much.